On this one, we're supposed to divide and simplify. So yeah, this is kind of a long one. So the first thing, what do we do with divide? Well, remember, we keep the first fraction, keep, and then change the symbol in the middle from divide to multiply, and flip the one on the right. That's how we always handle divide, is keep, change, flip, right? Because 10 divided by 2, 10 candy bars divided among 2 kids, 5 candy bars each, that's the same as half of 10. So I'm going to give you half of my 10 candy bars. That's still 5, same thing. So dividing by 2 is the same as multiplying by a half. I'm just proving that whenever we change from divide to multiply, you know from real life experience that dividing by 2 is the same as multiplying by a half. Half of 10 is the same as 10 divided by 2. So dividing is the same as multiplying by the upside down, the flip of the number on the right. So that's exactly what we do. So that's the first step. Let me come on down and do that. We're going to go over here. So we go time. We're going to change the symbol to times right there. Okay, and then we keep the one on the first one the same. But the one on the right we flip, right? X squared. Let's twist my size. Flip it. So we've got to flip the fraction on the right. We change to multiply and flip the fraction on the right. Now it's a multiplication problem. Now we can cancel. So now how do we cancel? Can I just go, yeah, 2x squared and 2x squared, x cancels x, these 3's cancel, x squareds cancel. No, that's all garbage. That's all baloney. Why? Why can't we do that? Why is that? What's wrong with that? That looks great. You know, we cannot cancel added, subtracted items. Instead, we factor. Why do we factor? Because that'll make them multiplied. We're only allowed to cancel multiplied items. So we got to factor it because that'll make them multiply. All right, now the factoring is not all that easy. How do we factor? Well, you're going to have to do it one at a time. This one's multiply and multiply here, right? So let's bring it on down. All right, on the middle here. Okay, so first stuff right up here, this is going to be your 2 parentheses and 2x. So it's going to be 2x, not 2x, 2x. 2x and regular x, right? 2x times regular x is 2x squared. And what multiplies to be 3? Well, there's actually a couple options, aren't there? Let me just do both options right here. 2x and x. Now you can have how can we do it here? We can have 3 and 1 or 1 and 3, right? What multiplies to be 3? 3 times 1. Now I haven't put the signs on yet. I'm gonna do the pluses and minuses in the middle, but it can be either of those orders, right? You with me? The 2 and the 1 can be together, or the 2 and the 3 can be together. The x with the 3 or the x with the 1, right? We could switch the order. Say I just put the 1, 3, and then I changed it to 3, 1. Either one of those is possible. Either one of those is possible. So which of those is really right? Well, we've got to check. So I don't know if there's room to check everything here, but I'll do it. I'll do it nonetheless. So I'm gonna have to check. Yeah, I'm debating in my mind where I do it all, because this is going to be a lot of work. Yeah, I'm just gonna have to do it, then erase it. Okay, so if I check, here's the check on this one. It's going to be, remember you do first to both, 2x squared. Oh, wait, no signs yet. 2x squared and 2x, and then boom, boom, 3x and 3. Now, can the 2 in the middle make them, what's in the middle? Minus 1x, huh? How can they make minus 1x? Minus, the sign in the middle goes in the bigger, right? Sign in the middle goes on the bigger. So Plus 2 minus 3 makes minus 1. So that's it. That's working perfectly. How do the signs go? They crisscross. Remember, this guy goes here. This guy goes here. They crisscross. So minus 3 times plus 1 makes minus 3 at the back, and they add to be minus 1. That's actually the right answer right there. That making sense? To see how that's true. So I'm going to erase the 1 on the top. The other one would not work. You know, if you want it here, maybe I could show it just out of interest. You go boom, boom. I'll show this doesn't work. It would be 2x squared, 6x, and boom, boom. It would be 1x and 3. How can the two middle ones make minus 1x? They can't. A 6 and a 1 add to be 7, subtract to be 5. They have no way of making a minus 1. See how that option is not right? It's the other orders. Everybody see that? That's just the first of 4. So this is hard work. You got to very carefully factor all these, and we can't do any of them wrong. Okay, so I'm going to erase this. We got the right answer. We factored one of the 4 only. Now we got to go to the second one. All right, I'm going to factor down here. These guys. Again, multiply, add, multiply. 2 parentheses. 2xx, multiply to be 2x squared. What multiplies to be 3? Well, at the back here, right? It's going to be 3 times 1, but again, there's 2 orders, aren't there? There's 2 possibilities. What are the different ways it can be? 1 times 3. Oh, wait. I'm going to do it right here first. 3 times 1 and 1 times 3. Either order, right? They're both possible. How do you know which one's right? Well, you just have to check it. So let's check it. And then we'll check the bottom. Boom, boom. That's going to be 2x squared, 2x. Boom, boom. 3x and 3. Can they, in the middle, make plus 5x? Yeah, if they're both plus. So both plus. That's right. That one's correct. The other one is not correct. If you check it, if you try to check the other one, you'll see it's not correct. You go boom, boom. The check on the other one is 2x squared, 6x, and boom, boom, 1x, 3. How can the 2 numbers in the middle make 5? Well, they can if you have plus 6 minus 1. That would make plus 5. But the problem with that, you do plus 6 minus 1, you put the plus here and the minus there. Then minus 1 times plus 3 would be minus 3, and we need plus 3. That's wrong. That's a tricky one. It almost checks, but not quite. Not quite. Everybody see that? So this is just hard factoring. You just got to do all these factored out very, very carefully. So it's not, you think, well, plus 6 minus 1, that's plus 5. Yeah, but a minus times a plus would make minus 3, not plus 3. So that one's wrong. All right, so that option on the bottom is wrong. So I'm going to erase that and erase all this. We've got the correct answer. Yeah. All right, there we go. All right, next one. These are a lot of work. Okay, this one right here. This one's going to be easier because it doesn't have a number in the front. Multiply, add, multiply. This one's going to be x's in the front. What multiplies to be 8? 4 times 2. How does it add to be plus 2? Plus 4 minus 2. That's easy, right? Plus 4 minus 2 adds to be plus 2. Okay, and then finally down here, multiply, add, multiply. 2x times x multiplies to be 2x squared. What multiplies to be 6? Well, a couple options. 3 times 2. Now, could it be 2 here and 3 there? No, remember that's not a valid option. I don't even need to check that one. Why not? Remember how you can never have 2 numbers in the same parenthesis that have anything in common, let alone are the very same number. That's not going to fly. No way. No way we're going to have two twos in the same parenthesis. Remember that? You're never going to have two numbers in the same parenthesis that have anything in common, let alone that are the very same number. For example, this couldn't be a 4 either because 2 and 4, 2 goes to both of them. Can't be a 6 because 2 and 6, 2 goes into both of them. Can't be an 8 because 2 and 8, 2 goes into both of them. Not possible. All right, well then what is it? Well, it's the other order. The 3 goes here and the 2 goes there. Right, that's how it multiplies to be 6. Good so far? Front times front, 2x times x, multiplied to be 2x squared. And 3 times 2 is multiplied to be 6 in this order. See how the 2 and the 3 have nothing in common, and then x and 2, there's nothing in common. So that's correct. What signs do we need? Well, you check it. You'll see, boom, boom. It's going to be 2x squared, 4x, and boom, boom. 3x and 6. What signs do the middle guys need to make -7? Well, both minus 4x and -6. If you lose $4 and you lose $3, you lost $7. So they're both minus. Is that right? -3 times -2 is +6. That's right, +6. Perfect. That is the right factorization. All right, that's the hard work. Now we've got them all 4 factored. Now, right, it's a long problem. Let me recap. From the beginning, it was a divide problem. What do we always do with divide? Change to multiply and flip the fraction on the right. And then we had 4 factoring problems. We factored all 4 of them, and they were difficult. Having to check them all, make sure they're all perfect. Very easy to make mistakes. Okay, now let's cancel whatever matches. You write that. Cancel. Top to bottom. Straight down or diagonally down. Straight down or diagonally down, doesn't matter. All right, so like I can cancel these 2 straight down, these 2 straight down, this 2x minus 3 and this 2x minus 3 diagonally. So what are we left with? All we're left with is x plus 4 on the top and 2x plus 3 on the bottom. And that's it. That's the answer to that very long and challenging problem. There we go.